first half of a two-part 2-Minute Tuesday brought to you by KCAS Bioanalytical and Biomarker Services. I'm John Perkins, the Senior Scientific Advisor for LC-MS Technologies. I'm here today to give an introduction to the quantitation of large molecules by LC-MS. A recent trend in pharmaceutical companies and biotech's pipelines has been a shift to large molecule therapeutics. This presents a challenge for bioanalysis by LC-MS because the molecular weights of the target analytes are well beyond the mass range of the mass spectrometer. Electrospray and ion spray ionization have become the industry's gold standard for interfacing HPLC, a high pressure separation technique, with mass spectrometry, essentially a high vacuum detector. Application of a high voltage to a liquid stream passing through a nozzle can ionize that solution and produce a charged droplet spray. Electrospray is a soft ionization technique that gives protonated or deprotonated molecular ions, but little to no fragmentation. For small molecules, we'll likely see a single peak in the mass spectrum, although adducts may also be observed. Using electrospray conditions, large molecules can acquire multiple charges, and this is the key to measuring them using mass spectrometry. The mass spectrometer actually measures mass to charge rather than mass alone, so the more charges a molecule can acquire, then the greater the likelihood of us being able to observe it. Investigators looked at this phenomenon. Horseheart Myoglobin was an excellent example of how this applied. With a relative molecular mass of 16,950 daltons, it was way beyond the typical range of a mass spectrometer. However, multiple charging in positive ion mode gives a spectrum with a range of charge states from around 15 to 27 to give multiply charged ions ranging between 600 and 1500. Sadly, the quantitation of intact large molecules is limited at present. Many of our assays are looking for ultimate sensitivity, so the spread of charges across multiple states dilutes the sensitivity available. Fragmenting a large molecule at higher collision energies yield a multitude of low mass fragments of little value. Lower energies can yield more specific fragments, but only in low abundance compared to the intact precursor. In practical terms, insulin analogues with molecular weights around 5700 can be quantitated down to low picogram per mole levels, and this represents somewhere near the top end of molecules that can be quantitated intact with sensitivity that's bioanalytically useful. Fortunately, there are other practical approaches to counter this shortcoming, and I will discuss them in my next 2-Minute Tuesday, so join me then.